I was saying f of k is in the y direction. That was silly. All right, sorry about that. Tired. Let's try this again. Let's look at the forces in the y. So let's look at the sum of the forces in the y direction. They do equal 0, and one is Fn, and the other one is mgy. Okay? And we know that mgy, mg in the y direction, is equal to mg times the cosine of 32.8. Because mg is your hypotenuse. This is your adjacent leg. This is right triangle. And that's your opposite leg. So mgx. So we know that. So this is a sidebar thing. This is where I'm just saying mgy is equal to this guy. So Fn is equal to mg cosine of 32.8. And we also know, the reason we start with some of the forces in the y direction, is because I want to be able to say, hey, what is the kinetic frictional force? Well, the formula for the kinetic frictional force is equal to mu naught k, which we know up here is 0.83, all right, times the normal force. So it is equal to mu naught k times mg cosine of 32.8. And you've got numbers for every one of these. This is 0.83, this is 192, this is 9.8 cosine of this. So you know the magnitude of that vector. All right? You know the magnitude of that vector. Now, let's look at the sum of the forces in the x direction. And then in the last video, we'll finish the problem. Or at least I'll stop and you all can work yours out just like this, ignoring when you're thinking of something else. All right, so you got some of the forces in the x direction, then equal, they actually have an acceleration of the log times 0.857. This is your MA. Okay, your MA here, your MA over here is equal to 0 in the y direction. But your MA in the x direction has an acceleration. M is the mass of the log, is equal to, let's just look at the forces, minus f of k, minus mgx, this guy, plus t. Kind of ran out of room there, so let's do the sum of the forces in the x direction. Now here's where some people have trouble. Yes, we do have two equal signs here. I can have 30 equal signs in a row if I want. A equals B equals C equals D equals E, 11 plus 4 is equal to 15, which equals 12 plus 3, which equals 13 plus 2, which equals 14 plus 1. I mean, it can go on and on forever. So you got this, f of x equals m 192, in my case, times 0.857, is equal to minus f of k plus, now what is mgx? Mgx is equal to the mass times g, and this is the opposite leg, times the sine of 32.8 degrees. All right? Plus t minus mgx, minus mg sine of 32.8. So your last, you got a number here for f of k. This has a number, this has a number, this has a number. This is the only thing missing. I mean, you've got to get used to, and we do this, I mean, you can't do physics unless you take something from somewhere else and plop it down in a new spot for some information that you need based on the physics of the problem. All right? So that's how this problem is done.